I'm going to write some code. You don't have to write it, you can just see what I'm doing. If you want, you can ask from me, I can send those codes. You don't have them at your site, at the professor's site. Okay, source 2. But you can ask me and I can send it to you. Have you heard about complex numbers before? Yes or no? Do you know what they're about? Yes or no? Let me refresh your memory. So you have numbers like a plus bi. For instance, z1 can be 3 plus 4i, and z2 can be 2 minus 5i. Those are complex numbers. I think you saw those numbers in high school. And do you remember what I was about? How much is I? Square root of minus 1. Unfortunately for you, you don't have, so we have seen integers, floats, doubles, and so on. But unfortunately for you, you don't have complex numbers as a type in C++. But hey, we are going to define one, okay? Using classes, a new type of number, a new class of numbers. How are we going to do that? So, we started with the new piece of code. I'm going to define the new class, which is called complex, meaning I'm dealing with complex numbers. You can see also the syntax of this guy. Private. What should I keep as private? Let's say that each complex number has its name. Okay, z1, z2, or whatever. So string name. And you don't want to tell this name to anyone else. But you have something which is public. And what's public? You see the way numbers are constructed, complex numbers, a plus bi. So the a part is the real part, and the b part is the imaginary part, if you remember it, okay? Those are made be of type float. So float, real, float, imaginary. Okay. Now, so far so good. Let's leave it like this. I'm going to define main. By the way, do you agree that we should punish those guys and girls that come late? Yes or no? I think we should punish them. Like what? Let's figure out a punishment for them. How about them buying us a bottle of Coke? Is it okay? Yes or no? Okay, just pay attention to this stuff. I'm saying integer a, and then I'm saying a is equal to 5. But I might also say something like this. Integer b, and write 5 here. Now when I print both of them, I'll get the following thing. A is equal to, again, as a string, b is equal to, and I'm printing b. Now let's run the code and see what's going on. A is equal to 5 and b is equal to 5. So what have we seen? That we can do it this way. Yes, we can do it also this way. But we can do it this way. Okay? And we will see why we can do it in different ways. If we run the code again, we will have the same result. A is 5, B is 5. I can tell you immediately, whenever I say A only, automatically an A is created and it has no values. If you don't trust me, we can go. So A is equal to 5. Let's say it's like this. Let's put a breakpoint here. I'm going to show some debugging stuff. And also here, and here, and here. So I'm running the program. Now see what's happening. I've defined A, and you see A has no value here. This makes no sense. I'm about to execute this piece of code, and I'm saying that, well, A is equal to 5. I can press either continue or go to debug, continue, and see this guy with red, this is A. It just took the value 5. Now I'm going to this line here. B, parentheses, brackets, 5. So debug, continue. Hey, B is also 5. See it with red, okay? Then I'm continuing. I just printed A is equal to B, then I have the scene ignore and scene get. Okay? Basically, when we have an object, a new object of a new class, of a new type, is created with something which is called constructor. That constructor makes that class, assigns memory, values for that class, and so on. We will see it in a while. So first, let's remove those red points. We will get back to them again. Remind me, please, if I forget. We're going to define a new function which is called complex. It takes no values, because you remember when we when we wrote integer A had no value, or value that makes no sense. Some compilers make A be 0, okay? In our case, when I define a new complex number, let's say if I define a complex z1, I want the imaginary and the real part to be 0. That's why I'm saying that the real, this guy real, is equal to 0, and the imaginary is also equal to 0. But sometimes I might call it like this: float A and float B, or real and imaginary. So this real guy is equal to RE, that we are passing as parameter, and the imaginary part is equal to IM. Okay. We want also what kind of operations we can define. We want to print our complex number. That's why we're displayed. Let's write a function which is void, because it's not going to return anything. It's called display. It takes no parameters because it's going to display the real and the imaginary in this way. So the display function, which is defined inside the complex class, is this way. I'm printing the real one, then brackets, empty space, or no, I don't want to do it, then imaginary one, and I put I in the end, and I have end line, or I don't want to have end line. This is how I display them. Furthermore, what can we do? What kind of operations can we do with complex numbers? With integer numbers, with float numbers, we can add them, subtract them, multiply, divide, and so on. Can we do the same things with more complex numbers? Yes or no? Yeah. I'm going to write only one function, which is going to be called void. And this function will be called add. It is going to take as a parameter another complex number. That's why we have complex, you see. We are defining the class, but it can take another complex number. Let's call this complex number z, And how are we going to define the class? We will say that the real value of this one, so how do we add two complex numbers? Let's say z1 plus z2 in the following manner. What I'm trying to say is z1 is equal to z1 plus z2. We have z1, z2 here. We just add z2. Z1 is taking z2 as parameter, and we want the z1 to be the addition of those two. So how much is that? The new z1 is going to be, the old z1 is 3 plus 4i plus, this is the addition, 2 minus 5i. This is equal to 5 minus 1i, or 5 minus i. Okay, this is complex numbers. That's why basically we add the real part with the real part and the imaginary part with the imaginary part. Again, the real part is this one that has no I, and the B1 is the one associated with I, multiplied with I. So I'm saying that real is equal to real plus z point. You see, I can add real here. These are the properties, the functions, the methods that we have implemented so far. But you see the name, we have something, a locker. It's locked. Why it's so? Because it's private. No one can see it. While the public parts, everyone can see it. So z, this real is the real of the number that is, let's say I'm a complex number, okay? And I have a real part and imaginary part. And you are another complex number, and you have real part and imaginary part. And I'm calling you as a function, okay? What I want to do is I want my real part and your real part to be added, and my imaginary part with your imaginary part to be added and be put again at my place, okay? But not change your part. Do you understand me? This is what we are doing here. So when I say real, I mean the real that I have. And when I say imaginary, this is the imaginary. Z point real is the real of the function that we just took as a parameter. It might be strange for the time being, but you'll see it's very easy. Okay, so far so good. We don't want to do anything else. Now let's go to main. We saw this kind of defining and declaring variables, and this one here. Now let's see what I'm going to do. I'm going to define a new complex number. The type is complex. Z1. I'm going to define another one, which is called complex, Z2, but I'm going to do it in the following way. 3.2, let's say, and 5.0. So what's going to happen? When I do it this way, what do you think? What's happening? It's no mistake. When I call it Z1 with no parameters, basically I'm saying that, well, the real and the imaginary part of this guy are 0. But when I'm calling it complex Z2, 3.2, 5.0, then I'm calling this one, that the real part is 3.2 and the imaginary part is equal to 5.0. You see, the name of the class is called complex. And we have defined functions, and those functions don't return anything. Void, integer, nothing. We don't write nothing. And we can define many constructors. Basically, those constructors help us to create the new object we have just defined, okay? We can do it in different ways, just as it was the case with integer numbers. So this complex number, if I don't take anything as a parameter, real part and imaginary part will be 0. If I take parameters, then the real part would be the first parameter, the second part will be the second parameter. Okay. Now, let's print those guys, or let me define another one, complex Z3. And Z3 has values minus 3.5, and the other one is 6.3, for instance, float numbers. Now let me print them, z1.display, I'm displaying it, z2.display, and z3.display. Okay, let's run this piece of code and see what do we have. Maybe we should put something like this. Cout, printing z1, which is equal to, and I'm printing z1. Printing z2, and I'm printing it. Printing z3, and I'm printing it. But before printing, let's put an end line here. We're going to make some changes, and you'll see why. Okay, so I'm printing the, what's the deal? Yeah. Z1 is 0, 0. I don't want those guys to be written like this. So I want to have plus or minus. That's why I'm going to change the display function. I'll do something like this. If the imaginary part is greater than 0, I want to add a plus. So I'm printing the real part, I'm adding plus, and I'm printing imaginary, and I have I in the end. Else, this is what I want to do. Cout, I'm just printing the real part. The imaginary, if it's negative, meaning if imaginary is greater than 0, I have plus. Otherwise, the negative part will be printed on its own. That's why I don't have to add minus, because the plus is skipped. And I'm printing the I part. This is it. Now let me run the code again. Okay, if it's greater or equal to 0, then I'm printing plus. Okay, so this is our code. Okay, is this understood? Yes or no? A kind of maybe. We will be back on that. Now we have seen the usage of this complex number, of this function here, of this one, and of display. Now let's see the usage of this one, add. So I'm saying cout that z1 is going to be z1 plus z2. That means I'm going to call this function z1 add, and z2 is going to be passed as a parameter. The result is z1 after adding is equal to, now let me print a new line here. Let me add z1. I'm pressing point. Each of those complex numbers has the methods, the properties, the functions we define. All of them, they have add, display, imaginary, name. You see, those guys are functions. Those here are variables. If it has this lock here, it's a private one. We cannot access it. If you don't believe me, just let's try to access the name. And the name is private. You see, it says is inaccessible, because only the object itself can see it, no one else. We will see how we can use it. So add, I'm pressing add here. I'm opening the parentheses, and then I'm expecting another complex number, which is going to be called z, but that complex number is going to be, in our case, z2. So I'm trying to add z1 and z2. Okay, so I'm adding z2. And I'm trying to print now z1 display. Let's see what do we have. z1 is this much, z2 is that much, z3 is that much. Now we are trying to find z1, which is equal to z1 plus z2, meaning we are calling this function. So the result is 3.2 plus 5i. Is it okay? Yes, since z1, the real part of z1 is 0. The real part of z2 is 3. 0 plus 3 is 3. Same applies for the imaginary part. 0 plus 5 is 5. Okay? Did you understand this part? Now, these are about classes. In order to save time, I'm not going to add new functions. You can define subtract, multiply, divide, etc., etc. I'm not going to do that. If you want, we can add something else in terms of like this. So I'm going to define z2 is equal to z2 plus z3. Basically, it's z2 at z3. So z2 is, I'm adding z2 and z3, and I'm displaying z2. Let's see how it's going. And if you check the values, they are correct. If I add 3.2, z2 plus z3, is there? Yeah, 3.2 minus 3.5 is minus 0.3. 5 plus 6.3. 5 plus 6.3 is 6.3 now. It is a mistake. Did we? Let me check it. No, yeah, this is the mistake here. You see? So the imaginary part is equal to imaginary plus the old imaginary and the new imaginary from the function that we just called. So yeah, this now makes sense, okay? The real and the real is this one. The imaginary part and the imaginary is here, okay? Any questions? Do I have to repeat it again? How many of you did understand this one? We're going to see it again. Yeah, I know it's something hard. That's why I told you to pay attention to. Yeah? Question?
Why did we give 0 to real and imaginary at first?
Let's go to that one step by step. Because I wanted to. 0 plus 0i is also an imaginary number. So let's go something like this. Let's use breakpoints and see what's happening in each of them. So, okay, well, I don't care about displaying, but I care about this part here. Here and here. Let's start and let's see what's happening. I'm going to use some debugging stuff. So I started. I have z1, z2, and z3, but they don't have anything here. I'm continuing. Complex z1. I'm just about to execute. I'm going step by step. That's why pay attention. I'm going to also explain debugging. Step into, step over, step out. You will see what it's about. You will understand those by those examples. I'm defining complex z1. z1 has nothing right now. When I say continue, you see here they have name as no value, real, imaginary, whatever. When I say continue, you see what happened? z1 got red, and the real is 0.00, and the imaginary part is 0.000. Why? Because we called this function here. That's why. Now let's press it again. We are just about to execute this piece of code. So continue. With red, we see the last changes. We have the real being 3.2, the imaginary being 5.0 of z2. This is it. Now we are about to execute the third statement. You see we don't have anything here. Real is minus blah blah blah, imaginary is something that makes no sense. When I press continue, we have the new values. Because we called this time this function here, complex, float, real, and imaginary. Okay, is this clear? Now let's continue printing z1. We see here we don't have anything printed. So when I press continue, I'm going to display it, printing z2 and so on. I have all of this stuff here done. We are just about to execute this line. I'm executing it. I'm also adding and displaying. After adding z2 and displaying z1, you see z1 changed to 3.2 and 5.0. Previously it was 0.0. It's now in red because we just changed it. Now we see the results here. Now we are about to execute this one here. z2 is equal to z2 plus z3. See the value of z2? It's 3.2 and 5.0. When I press continue, it has changed, but we didn't see it because it finished. We see it printed here. Okay? Now, if you still didn't understand it well, I'm going to make some changes because the name here stays with any value. So when I'm calling it without values, as is the case here, the name is going to be an empty string. Otherwise, the name here is going to be no name, like this. Now, let's see something which is very interesting. If you want to know, if you are having mistakes, if you want to debug your code, you can go line by line, not with breakpoints, but with something which is called, you'll see it in a while. So, again, I'm going to do it in a different way. We have z1, z2, z3. Name, error, missing, real, nothing makes sense because we didn't start yet. If you go, remember this one, debug, step over. We go line by line without using breakpoints. So step over, F10, we are here, just about to execute this one. We didn't execute it yet. Again, debug, step over. We just executed. The name is, you see, empty string. Why it's empty string? Because we called this function here. Real is 0, imaginary 0, name is empty string. We are now just about to execute this one. So debug, step over. You see the name is no name. Why? Because we changed it here to be no name. And the real is the values we just passed as parameters. 3.2 and 5. 3.2 and 5. Okay? Debug, step over. The name is no name. The values we had them. Again, debug. You see here we don't have anything printed here yet. Maybe we can show them like this in parallel. So again, debug, step over. I'm printing z1. Maybe you cannot see it, but we are here now. So I just printed z1. Now I should display z1. And when I want to display it, this function is going to be called. This is the function that I'm going to use. Display function of the type z1, of the variable z1. So debug, step over. I displayed it. Okay, printed it. Debug, step over. I'm printing z2. Again, you can use F10, but I'm going to use only debug step over because of the recording stuff. We are printing it. Now we should print z3. Again. Now we should print this stuff here. We are just about to print it. Now we should add those two numbers, and you should see the change here. z1 add z2. z1 is for the time being 0. The real part is 0, in the imaginary 0. Afterwards, you see we have changed them. Now we want to display the changes, so that's why we are printing it. We printed it here. So up until the end, step over, we are printing this stuff. Now we are adding and displaying it. So step over again, we have the changes here, debug, step over. And this is it. So we can go to see and ignore and see and get. If this is still not enough, so step over goes line by line. We don't have to use breakpoints. If you're still not satisfied with this guy, I'm going to tell you about something which is more interesting. And that interesting part is called step into. So pay attention to step into. So local, we start. Now, we don't have anything printed. If you want to see, when we go to this guy here, how it's going to execute this command here, we are going to use step into. We go inside that one to see what's calling. But before doing it, let's change that. The name should be blah, blah, blah here, when we have no parameters. So, we start. Let's go with step over. Now we are just about to execute complex 1. With step into, you go inside that function, you see how do you execute it. Basically, I told you we are going to call this function here complex. So, we go debug, step into, not step over, step into. You see we went to complex. Okay? Now let's go line by line here and see what's happening. Line by line is step over. The real part is about to be executed, debug, step over. The real is 0 now. Now we are about to execute imaginary. See, imaginary is still not executed. So debug, step over, imaginary is 0. The name has nothing here. We are just about to execute this, and the name should be blah, blah, blah. Step over. The name is blah, blah, blah. We are finished. When we finished, we go again, step over. We are here. If I say step over again, we are just about to execute this z2. But what do you think? This z2, which function will be called here? The one which is called the complex with parameters. If you don't trust me, go debug. With step into, you go inside the command. So step into, you see we're calling this function, real and imaginary. So z2, for the time being, we have here the real and imaginary part, but the function that we are calling has no values for the real and imaginary. We have question marks. Let's go line by line. Step over means line by line. Okay, the real part should be the real. It's 3.2. Yes. Again, step over, it's 5. And the name is, for the time being, empty. We want it to be no name. Debug. Step over, it's no name. If I say step over again, we go here. Did you get it? So step over, go to new line. I can go step over again, but I want to see how this is executed. How did the Z3 got those values? That's why we use step into. I know it's a bit of weird thing, it's maybe hard, but I don't expect to understand me 100%, but at least you should follow me. You'll have the videos and it will be much clearer. You can see them a couple of times, 3-4 times, it will be much clearer, okay? There's another function which is called step out. Step into, you go inside the function. Step out, you go outside. Okay, so step out, you go here. Let's go step over, again step over. Now we are about to call the function display of the complex number z1. How are we going to do it? Again, if you want to see how it's working, go to step into, and we are executing display. You remember z1 has a real part of 0 and imaginary part is also 0. So we go line by line. If imaginary is greater than or equal to 0, is this true? Yes. That's why this part is going to be executed. We don't have anything printed. Now it's going to be printed because we are printing it with this cout. Step over. You see it's printed now. 0 plus 0. This else is not going to be executed. That's why with step over we go here. And now we print it. Let's go step over. Z.display. Let's see how z.display is working. Step into, we go to the display function of Z1, of Z2. Now let's go line by line. Debug. Z2, nothing else. Imaginary is greater or equal to 0. Yes, this is true. That's why we are going to have this one printed plus. Okay, we are in the end. We are printing this guy, step over. Now Z3. Interesting part is that we have minus 3.5 here. I mean, it's going to be the same thing. Let's just keep it with step over. Again, step over. Let's see how add is working. So Z1 is calling add Z2. We are going to go inside the add function now. And you see that this, meaning the function, which is Z1, has those values. Real is 0, imaginary is 0. So step over, real becomes real plus. That's why we see that real is changed. Again, step over, real is 3.2. The imaginary is going to be now added. Debug, step over, 5.0. It's changed. And we are finished. We go to where we left. We are displaying it. Step over because I don't want to go to see display. Again, step over. Now let's see how this one works. You see Z2 is 3.2. The real part and the imaginary part is 5.0. And Z3 is minus 3.5 and the imaginary is 6.3. So debug. I want to go inside the add function of those two and see how it works. So into, and I'm going to add them. You see, this has the real and imaginary part which are going to be changed. And Z, the one that I've got as a parameter here, has minus 3.5 and 6.3, which was Z3. So debug, step over. I've changed the real to 3.2. Step over. Step over. The imaginary also is changed. Now I go to where I left. And I'm here. I'm going to display it. I'm displaying it again. It's displayed here. And this is it. I know that it's a bit hard. How many of you understood this one? Step into and step over. Oh, if you all did, very nice. So step over goes line by line. Step into, you go inside the function. Step out, you go outside if you don't want to check it again. Why I'm saying step, you should go outside. Well, let's say that we are here. And do you want to see how this out is executed? Then yeah, you can go debug, step into, and this is something that you have not written. Okay, if you understand it, this guy, you're going to be a hacker probably. But this one also is calling something else. So if you go debug, step into, debug, step into, I mean, you'll see something that calls something else, that calls something else, which is hard for you. That's why you step out and you go where you left. Okay, so far so good. But we have something else I have something else to tell you about. It's about politeness. So, I'm going to add a new header file. You'll see what's that. I'm going to call it complex.h. I'm adding it. Now, I'm going to copy paste this part here. Just pay attention to what I'm doing. And I'm pasting it here. Probably I'll need those two also. IOStream and namespace. Okay, so this is going to be again 140. I just copy paste it. Now I'm going to delete this part. You'll see why. Basically, I'm going to use prototype functions, and you know what prototype functions are. I'm just declaring them. Delete, delete, delete. So basically, this is a good way to see that the class complex has a private variable called name. We didn't use it much, but it was just to show it what's private, what's public. It has public variables. One of them is called real, imaginary, they're both float. We have constructor. The constructor is the first function that is called when we declared a new variable. You remember when I said complex z1? And if I don't give parameters, this one is going to be called. If I say complex z2 and I give minus 3.2, 5.0, this one is going to be called. Okay? So always when I declare a new variable, it's going to be called this one. If I say string and name, the name of the string is name, it also has a constructor that is going to be called. Okay? I've also declared a function which is called display to print it, and function add to add two complex numbers. Of course, you can add, multiply, divide, or whatever. You can do whatever you want. But here, I've just declared the functions and I've not defined them. That's why I'm going to do something like this. Add new item. It's going to be CPP. Its name is going to be complex.cpp. I've just added it. Let me just copy paste this part here because probably I'll need it. Let me enlarge. Okay. Now I'm going to do something which you are going to understand what includes are about. Now, include, you see, I open the quotation marks and I see complex.h, and this complex.h is this guy here. Basically, what I've done is I've created a new library that I can use. And some smart guy has created IOStream the same way, and you just include it. But this IOStream is inside your compiler, it's inside Visual Studio. And this complex.h is something that I did. That's why it's in quotation marks. So I'm including complex.h. This is in quotation marks. And now I want to define those functions here. Complex. Let's see how was complex defined. It was defined like this. So I'm just going to copy it from the file that we already saw and go here. But we have a mistake here telling, well, I don't know. We should write something like this. Complex, 2 points, 2 points, complex. This stuff means that from the class complex, which is in this header complex.h, let's define the function. And the function works like this. Now let me define the other function, complex, the other constructor. I have another complex. You see we have another complex here. Let's say it's float. What was that? Real and float imaginary. I think. Yes. Now let's see how we did it here. Just copy and paste it. Okay, this is how we did it. I'm going to copy it and paste it here. We don't have any mistake. You should also be polite in the lines. This is the way you should use lining, okay? Because you make mistakes. Now, let's define. Let's write which function? Display. But this display in the beginning has void, if you remember here. See? Display has void, and this is how it works. So I'm going to copy and paste display. And display takes no parameters here. So I'm going to complex.cpp, open and close the brackets, and I'm writing display. Okay. You can minimize those like this if you don't want to see them. What is left? Void complex. Remember the function add? And this function add takes another complex number, which was called z. So let's write it here. Okay. it was done in the following manner. I'm going just to copy and paste it. We don't need it again. Okay, so this is the way, and from here, basically, you can do it in this manner, and here you use it. You use the main, but we don't want to do it like this. So instead of doing as I did it, usually it's not wrong. It's right. It's working. I'm going to delete this part. That's why I'm going to have two headers, two new files. One of them is the header .h. When I'm going to do the following part, I'm just going to define how it looks a class. And here, just going to declare it with prototype functions, with variables. And here I'm going to define how those functions look. But remember, you have to write complex, 2 points, and write the functions. I'm writing complex is the name of the class is called complex. Okay? And here I write the codes for those classes. Remember, I have to include complex.h in order to do this stuff. Otherwise, I'm not able to do it. So let's go to source 2. And in source 2 is you have those dashes. Why? Because it doesn't understand what a complex is. We did it. What do you think? What should we do here in order to understand this file? What? Include complex something? Yes. If you think about that, yes. So we can say include. No, include complex, yes. This is it. You might say, why don't we include complex.cpp? We don't have to. Although complex.cpp tells the behavior of the functions in the complex, we don't have to include it. It's already automatically done. So here in main, we can just run the program, and this is it. If you want, we can use breakpoints again. So I'm starting. It's working. I don't see any output. Let's go with the stuff that we saw previously. Step over. Now let's go to complex.z1. Let's see what's going to do, but step into. Which function is going to call? Step into. You see it goes to complex.cpp and calls this function here. Okay? So debug, step over, step out. Step over. Let's see this one. What is going to be called? Step into. We are going to call this the other complex. Okay? Otherwise, everything is the same. Okay? Did you understand this one? Questions? Yeah?
Why are we using the numbers?
Because this is the polite way of doing things. Yeah, you are right. In this file here, we just declare the functions. In this CPP here, we don't have main. We just define how those functions that we declared, how they should behave. In this CPP, usually it's called the main.cpp, where we have the main function when we can use the utilities, the definitions which I already did.
And we just write them in the header?
Yeah. I mean, yeah, it's kind of a header. Okay? So IOStream is also a header. Someone else wrote IOStream. We're including it in order to use cout, cin. The same applies to using namespace, std, and so on. So we defined a new type called complex. You don't have those at the professor's site, okay? You can ask for me to send them to you. But I think it's beneficial. If you understood this one, the next example will be done in like 10-15 minutes. Any questions about this one? How many of you understood it? Be real. If all of you understood it, I'm really happy that you understood it. Even if you understand it 50%, it's sufficient. You can come to my office hours, call me, email me, watch the videos, etc. You'll have 3 minutes of break. I'm sorry, we don't have time.